Thanks, everybody. Can you hear me in the back? Good? Great. Okay. Here's the real talk. So thank you for coming to my talk, everybody. I'm Andrew Kelley. I am the creator of the Zig programming language, and I'm going to tell you a little bit about this project. This is going to be long, it's going to be technical, and it's also going to be high level and spicy. So we got a mix of all the different flavors. So let's get started. Let's see what kind of programming experience y'all have. So raise your hand if you would say that you have experience with Java or Go. Okay, that's a lot of the audience, like more than half. Okay. Who has experience with Python, Perl, JavaScript, Ruby, scripting languages? A little bit less, but also about half, I would say. Who has experience with C, C++, Rust, systems programming languages? Wow, okay, a little less. I would say maybe 40%. Pretty cool. Who feels like I didn't cover your favorite language and you feel left out? Okay, about like 15%, I would say. Okay, great. Perfect audience. All right, welcome. It's 9 a.m. It's time to read code and spot the bug. So who here this is your first time ever seeing Zig code ever? Okay, that's most people. Okay, cool. Does anyone already see the bug? No hands. Okay, good. So let's try to do this exercise where we try to debug something in a language that most people are seeing for the first time today. So here's kind of the setup code. We're going to do some metaprogramming. So the goal of this code is that we're going to do metaprogramming that counts the number of fields in this data struct. That any field that starts with count underscore, we want to treat that as a number and add all these together. And we're going to have a generic metaprogramming function that can do this. So here we're calling our function count stuff, and we've initialized it with 12.34, 100, -1, and we're getting the wrong answer. So there's a bug here somewhere in here. Here's the bug. So here we're doing a for loop over the struct fields. So count underscore donations, count underscore happy people, so on. Here we're checking if the struct field name starts with count underscore. And here we're switching on the type. So is it a float? Is it an int? That sort of thing. And we add, if it's a float, we add to the accumulator. If it's a integer, we convert to a float, add to the accumulator, and so on. Okay. Does anyone see the bug? We have 1, 2, 3, 4, 5, 6 hands. Okay. Can someone shout out the answer? You got it. So we missed one of the integer types. And if we do this, then we fix the bug. And we could have had a compile error this whole time. If we would have just done exhaustive, like you said, and had an else and said compile error, then we actually would have got a compile error for this and never had a bug in the first place. Okay, so what was that? 6 people here. You just debugged code in a language you've never seen before in what's usually the most complicated part of any programming language, reflection and metaprogramming. All right, so now that we got the warm-up out of the way, here's kind of the talk overview. So we'll dive into what's the Zig project. I'm going to tell you about our motto, maintain it with Zig. I'm going to tell you how to predict the future. And then I'm going to show you what are some projects that use Zig in the wild. I'll give you a little taste of the language. And then, okay. So let's talk about what's the Zig project. Other than the little cute space lizards that we have, I have stickers. You can have them if you want. If you go to the website, we call it a general purpose programming language and tool chain for maintaining robust, optimal, and reusable software. But I want to tell you kind of more of the backstory here. So I love this quote from Rui. Rui is this guy who makes the Mold project. It's a new linker that is really fast, way faster than all the previous ones. And he writes, it might feel a bit spammy, but my strategy is to increase the value of the commons by, say, 100, and just try to get 1 as a return. So bear with me. If you want to use Mold for free, you can just do that. This is my open source business strategy. I love this quote from Rui. And that's what we're trying to do as well. We're trying to increase the utility of the commons and just incrementally improve technology of what we have. What we're trying to do is re-examine the fundamental building blocks of software, kind of like cleaning up under the rug, right? Get all that dust out of there. So some examples of this would be memory allocation. In Zig, we don't always assume that there's a global memory allocator that you can always use. We pass allocators around just like any other parameter. Another example would be dependency on libc. Sometimes it's the right thing to do, but in other cases, if you're making a game for Windows or if you're trying to ship a static binary on Linux, you might not want to depend on libc. So we challenge some of these basic assumptions that usually people take for granted. One of our goals is to try to raise the standards of software as a craft throughout the industry. So I don't know if anyone else in this room feels like I do, where I'm so frustrated when I see bugs on the websites that I use for my daily life. If I'm trying to use my healthcare system and it's erroring out, or I'm trying to use my bank and it's not working, I just want us to do better. I know we can do better, and I really want that to happen. And that's part of what our goal is with the Zig Software Foundation. So part of the way that we do this is with tooling. So for example, we have ZigCC, which is a drop-in C++ compiler, which has better defaults to help catch bugs. We'll get into that. What else we're also getting into is providing robust, high-performance open source libraries for everyone to use for free. We just want to give that to the world. That's going to be coming a little bit later on. We're still kind of in a more initial phase before we get to this part. But that's going to help not only Zig projects, but all languages, because every language speaks the C ABI, and so if we help these core libraries get better and they use the C ABI, everybody wins. And finally, we care a lot about students. We want to help students learn how to be ethical and how to learn and teach them how to level them up so that they can get very good at their craft and help us take us to the next phase of computing in society. All right, so that's kind of our backstory. Now, here's our motto: maintain it with Zig. It's kind of like multiple levels that you can get into. So like level 1, you decide, I want to use ZigCC. I want to drop in this alternate C++ compiler. All right, why would I want to do that? Uber has decided that they like to do this because it gives them hermetic builds. This is where you don't depend on what's installed on the system. So you give everybody the ability to create production builds or create reproducible builds on whatever computer they're using. Is it a Windows? Is it a Linux? Is it a Mac? It doesn't matter. You just run the tool, you get the build, you get to test it. You can watch this talk by Modius if you want to learn about this. This is how you can find the talk, How Zig is Used at Uber on YouTube. Another reason you might try out ZigCC is better defaults. So for example, this person, John McFarlane, is complaining that how come C compilers, why are they afraid to break compatibility? They're always so careful to never break compatibility. And there's good reasons to not break compatibility, but ZigCC is an opportunity where we could do that. So I'm happy to report that, number 1, using ZigCC as a drop-in compiler is growing in popularity. Number 2, it enables undefined behavior sanitizer by default. And number 3, real-world applications. We're finding bugs in real-world applications and fixing them. So here's just one example. I was just doing a little side project. I found undefined behavior in SDL, sent them a pull request, or I sent them a diff, merged, done, problem solved for everybody. Next, why would you drop in ZigCC? Well, it gives you cross-compilation. So you could, for example, with just passing one flag, you just say the target that you want. Here I say x86 64 Windows, it works. And that works no matter whether I'm building on a host of Linux, on Mac, or Android, whatever, it doesn't matter. I could also say that I want to build for the M1s. I can cross-compile for that one. I could cross-compile my C++ code. That also works. I could also say that I want to target a specific glibc version. So maybe we deploy on, like an older Debian Linux, which uses glibc 2.31. There you go. You can just target that version. Or maybe I want to create a static build. I can use the muscle libc And then I get a binary that is distro independent, works on every Linux because it doesn't use libc at all, or it doesn't dynamically link libc. All right, and finally, I prepared a little demo here for built-in caching. So the idea here is that Zig needs to cache global stuff like libc and compiler RT. There's some stuff it needs to cache, and so we also just naturally extend this feature into basic C objects. So I'll play this for you, and I'm going to talk over it. So for people who are watching later online, you can just push play, and I'm in audio on here, but for you live, I'm going to just talk over it. Is it big enough? Yeah, what a beautiful screen. Okay, so here I'm looking at the Facebook Z standard library, and you can see it's just a git checkout. And they have a make file. That's how you build. It. It's actually kind of complicated. If I scroll down, it's got, I don't know, 400 lines in here. But they also have a bunch of recursive make files too. There's a lot going on here. But that's not all. They also have a CMake build. So they kind of like couldn't make up their mind which build system they wanted. It's weird because this project's not that complicated. It's mostly just some C code. So if you just list out all the C files that you want to build, you can just create the library no problem. So here I'm just demonstrating that with one command where I'm just putting a bunch of C files on the command line, and obviously we could put this into a script or something like this. You paste it. It's going to take a little bit of time to build the first time, 4 seconds or so. But then let's say I was working on this project and I was using this method to build it. I could then just go in, I could edit a file, just make some change, for example. If I build it again, it's going to be faster because it's of the caching system. So that was, what, 200 milliseconds-ish? But point being, like we didn't need to use that CMake or makefile or whatever. So depending on the size of your project, you just want to fool around a little bit with C, C++. This could be good enough for you. And then finally, it's so easy to install this and play with it. So how many people here have gone through the trouble to install Microsoft Visual Studio? See, like, I don't know, 40% hands? Yeah. It once took me a full 24 hours and 2 system restarts to do this. I mean, if you look on the internet, I mean, there's a lot of people complaining about it. This person's saying, why is it so slow? Its speed is averaging at 50 kilobytes a second. Closed. Low priority. Damn it. Why does it take so long to install Visual Studio? Visual Studio installer is stuck. Oh. So for contrast, if you want to install ZigCC, you just go to the download page, find your operating system here. It's a 60 megabyte zip file, and you just unzip it. You don't got to edit the registry. You don't need to, worry about restarting your computer. If for here I timed it, it took 5 seconds to download and unzip it, and then it's done. So it might be easier to just play with C, C++ that way than to wait, 24 hours for MSVC to install. So that's level 1. That's if you want to try out a I don't know, maybe it's kind of like C, C++ compiler with the seatbelts on, But once you get past level 1, maybe you want to play with level 2. Level 2 is when you exploit the Zig build system. And so I showed you that command line where we could just paste a bunch of C files in there, and okay, you could throw that in a shell script or something. Or you could create a build.zig script. So here I'm showing you an example. And this is the whole file, but I'm highlighting the line where we create an executable. And here it's a little demo of creating a little Tetris game. There's no Zig code in here. We're not building any Zig code. The build script is Zig code, but we're just building C with this. You can see it's main.c. We have a dependency here, and that's all. We also have a user-defined option to build for Windows, and we also created a user-defined build step called play. So if we take a look at running Zig build on the command line, the help menu is integrated with the declarative API. So the play step that you added shows up in the help menu, and the flags, the user-defined flags that you added show up there as well. And then finally, this is vaporware, so not ready to ship yet, but coming soon. We'll also be fulfilling C and C++ dependencies with this system. And that will be more reliable for people that are collaborating with you than hoping that everyone has the right things installed, especially when your collaborators are on different operating systems than you. So that's level 2. And once you get there, it's not that much further to try to, you might start thinking about level 3, write a component in Zig. Because, you know, if you use the Zig build system, you took on a new dependency, which is Zig, but you also got rid of a dependency, such as CMake or make or something like this. So you did a swap. And to go to level 3, you don't have to take on a new dependency. You're just exploiting the one that you already added. So you already depend on Zig. Well, why not go ahead and just throw some Zig code into your project? And the nice thing is that it integrates super well. So in this example, we have a build script. We're going to have foo.zig bar.c. I'm going to show you how they can call into each other. So here's our Zig file, and there's 2 things here to point out. One, we're exporting this function called dump stack trace, and you can see that all it's doing is just forwarding directly to the standard library, because the Zig standard library has a function called dump stack trace, or dump current stack trace, which is super handy sometimes. So maybe you want to expose that to C. There you go. It's 1 line to do that. And then the other demo here is that we have a function that's going to take a array of integers, sum them together, return the result. Now this is using a slice as the parameter, which is not a C concept. So we have to export a C ABI in order to do that. So this is a wrapper function that provides the sum array function. And finally, we have a line here that tells Zig that it does not need to provide main because C will be providing the main function. Okay, here's our C code. In our C code, you can see that we're declaring the 2 imports that we get from Zig. And we have our main function, which is going to pass in an array that we can get the result and print it. Okay, so everybody shout out what's the answer to this input? 20. Good. Keep you on your toes. Hope you had your coffee. So that's right. And then also we're going to say if the user passes an argument, doesn't matter what it is, but if they pass an argument, we're going to dump a stack trace. So that's what this code is going to do. Okay, so here we have this in action. We can run our Zig build command to create the binary, and we run it, and y'all got the right answer. Nice. If we pass in arguments, then we get a stack trace. And look at the stack trace. It's pretty sweet because the, let's see if I can get a mouse cursor over here. Yeah. The stack trace has Zig files in it, right? And it also has C files in it. So you can see that it integrates really seamlessly with each other. But that's not it. We also have LTO. So I'm showing you this code again where we knew the answer was 20. And here I'm doing an optimized build. And here we're looking at the x86 machine code that we're outputting here. Now, does anyone tell me, can anyone tell me, like, where's the call to sum array? Like, we should see, like, we see the call to printf, right? That makes sense. Where's the call to sum array? It seems to be missing, right? Can someone tell me what's 20 in hexadecimal? Nope. 20 is in decimal is what in hexadecimal? I'll give you a clue. It's one of these lines right here. Yeah, it's this one. This is 20 right here. So when we did optimizations, the Zig code didn't even end up being generated because it got optimized so much that it just figured out the answer was 20 and then just sent that to printf right there. So that's the default that you get when you mix these things together. All right. I took you into low level. We're gonna go back up high level again, and then we'll go right back down into it. But let's take a little break. So, how to predict the future? We got some nice AI generated bedroom here. That's the future, AI generated bedrooms. All right, so let's play a game. I'm gonna just throw some logos into 2 categories, and you gotta try and guess what categories I'm thinking of. Or just, I don't know, any 2 categories that fits. All right. Here we go. And we can shout out some of these names. What does the elephant represent? Yes, Postgres. Everyone knows Wikipedia. What about the penguin? Yeah. What about the dragon? Yeah. Okay, what about the red, blue, green box? Yeah, GTK. Who got that? Nice. That one was the hard one. Okay, does anyone have any guesses on what the categories are? No, because SQLite, Qt, and macOS and MongoDB are open source. Yeah, that's the good answer. So the left is nonprofits and the right is for-profits. Side note, I hate this name, OpenAI. It's closed source proprietary. Nothing about this is open. What the hell? Is anyone surprised about SQLite? We'll get to that one. That one's interesting. So let's talk about nonprofits versus VC-backed startups, venture capital. All right, so profit is revenue that you make minus the expenses you have to pay. That's pretty straightforward. And the question is, what do you do with profit? So in a for-profit company, the whole point is that you make profit and the profit goes to the owners. That's the goal. So success is defined by the owners gaining wealth. That's good. Nonprofits are a little different. So maybe you still have excess revenue. Maybe you have revenue that exceeds your expenses. But you have to take that profit and you have to reinvest it into the mission statement. So success is defined by fulfillment of the mission. Nobody gets rich. We only do what we set out to do. Let's talk about venture capital-backed startups specifically. I told you that this was going to be about how to predict the future. Well, it's very easy to predict the future of venture capital-backed startups. Here's a timeline. All right, year 0. They spend VC money to make a seductive, unsustainable product that customers flock to. Year 5. The VCs squeeze their grip. The startup starts going to shit. Employees and customers suffer as they prepare their exit strategy. And this is when it's going well. This is when it doesn't die. Finally, year 7. Roll a dice. 99 times out of 100, they get bought by a large corporation as a talent acquisition. The company effectively dies, leaving customers stranded or awkwardly absorbed by their new parent. Or 1 out of 100, they hockey stick, and 20 years pass, and now they're a large corporation. Anyone recognize these? The Wikipedia logo is from the year 2000. The Google logo is from the year 1997. So these were contemporary early web websites, both really highly regarded. Everyone loved these websites. Wikipedia was a 501c3 nonprofit, and Google was a limited liability company. Fast forward to today. Wikipedia, still a 501c3 nonprofit, still awesome. Everyone still loves Wikipedia. Google, publicly traded since 2004, pretty much widely regarded as an evil large corporation at this point. How many people here used Fitbit? That would include me, actually. 1, 2? Wow, only 2. Okay, well, 2 people. Well, congratulations, Google has our data now, whether we like it or not, and even though it's dead. I'm going to digress about all my complaints about all the negative experiences I've had with startups, but maybe we can all think of some that we've had. Let's talk about privately owned businesses. These are a bit more stable. They're not, trying to do that hockey stick thing, so they're more of a steady trajectory. But probably the owner wants to retire and cash out at some point. They get old, they want their kids to go to college or something like this. Sometimes it stays a family business, but this relies on brittle factors. Maybe one of your children doesn't want to take on the mantle. So as an example, my dad has worked for a roofing company called Progressive Roofing for most of his career. They're a really well-regarded company. They make great roofs. They do good work. They make their customers happy. But the guy who owns the company is getting old. He wants to retire, and none of his kids want to take the business. So they sold it. They sold it to some big roofing corporation, and I'm hearing all these horror stories from what's happening from my dad, and it's the same story, you know. Another interesting case study to look at right now is RAD Game Tools. This is a privately owned company that is very well regarded in the games industry. Pretty much everyone who works at this company is like a minor celebrity on the internet for just being like very good at their job. And they just got bought by Epic Games about a year ago. No more news to report since then, but I'm making a prediction today that we're going to see those mini celebrities who work at RAD Game Tools quit working at Epic and go do something else. And then it's basically dead. It's the death of this great company. Another case study is SQLite. So this one's very interesting. This is also run by a privately owned company. SQLite is an excellent piece of software. Everyone loves it. It has a consortium that companies can use, they can pay to join to get better support. To me, this seems like an excellent business model. I think it's the right way to go. But we have yet to see the owners of the company, of Hipwick and Company Incorporated, reach retirement age. So I wouldn't be surprised if the company gets sold in 10, 15 years. And I'm saying all these things not from a moral perspective. I don't think morality has anything to do with these things. If you want to get rich, that's great. But the point is that we as customers or as stakeholders in these companies can predict what will happen to these companies in the future. And we should absolutely use this information to our benefit to better predict what will happen to us if we depend on these tools. So, I mean, obviously what I'm trying to tell you is that I represent a nonprofit, and as a nonprofit, we have your best interests in mind compared to some of these other nonprofit businesses. This is basically what I was just saying. So let's talk about Zig Software Foundation, which is a 501c3 nonprofit. We have already achieved financial stability. Our revenue exceeds our expenses. But as our revenue exceeds our expenses too much, we give that money to contributors who are doing work. So we move that money towards our mission statement. But we're already stable. We have already released a useful working product that is solving people's needs. We have a happy, talented, self-directed staff. People love working, all four of us love working for Zig Software Foundation. We have an ambitious roadmap. We have a secure future. We don't have any VCs wanting a return on their investment. We don't have runway that's going to be gone. We can focus on our mission. And I'm not the boss. The board of directors is the boss. So you, the customer or the stakeholder, knows that when I'm gone, Zig Software Foundation will still operate according to the same mission statement. It's not going to get sold to Epic Games so I can send my kids to college or something like this. So we've already succeeded. All right, I'll show you now some other people who are using Zig to their advantage, Zig in the wild. Zig is a general purpose language, which means it gives you the tools to generate the best possible machine code for the target, whether that target is an actual piece of hardware or a virtual machine, such as WebAssembly. So it's applicable to anything resembling a von Neumann machine, which is most computers. But there's some cases where Zig truly excels, thanks to its conservative language design choices. So I'm going to show you just a couple examples from everything in these categories, but don't worry, these slides are fast and colorful. So first we have low-level infrastructure. This is the River window manager. This isn't mine. I grabbed this from some subreddit where people show off their desktops to each other. But a window manager is one of those tools where it draws your windows on your desktop. And River is a really nice project that's written in Zig. Next we have Bun. Bun is a fast all-in-one JavaScript runtime. Very cool of Jared to put this little section on their homepage. He writes, "Why is Bun fast? An enormous amount of time spent profiling, benchmarking, and optimizing things." He really put a lot of time into that stuff. "The answer is different for every part of Bun, but one general theme: Zig's low-level control over memory and lack of hidden control flow makes it much simpler to write fast software." And he put a little call to donate. Man, very cool. Thank you, Jared. Next, we have libraries to be used by higher level languages. So as an example, we have Zigler. This is a Elixir native, what does NIF stand for? Native something something. Point is, you're using Elixir, which is high level, and then you want to be able to do some low level stuff. You can use Zigler for this. So here's just kind of an example of it in action. I'm not going to go into this, but it's some Zig code next to some Elixir code. But the point is that the level of degree of smooth integration that Isaac Yonemoto was able to accomplish here was incredible. So if anyone is interested in Elixir, definitely recommend to check this out. He's got a talk you can search for called Zigler Elixir FFIs with Zig. He also has a talk from Elixir Conf, and it's Isaac Yonemoto is the guy. So if you're into Elixir, check this stuff out. It's very cool. Another example is the VFX plugins. I just saw Jim from DNAG do this presentation in Vancouver last week, and this blew me away. So I can't link to his talk yet because it's not up yet, but he showed that when he was trying to render a bunch of sand, he was able to use Zig to write a plugin to save gigabytes of bandwidth on their network by procedurally generating the sand. So that's another example. When this talk comes out, I recommend it because it was excellent. Another example of Zig in action is high performance applications. So this is my personal, white whale. Before working on Zig, I started working on this digital audio workstation. You can see I didn't get super far on it, but I'll get back to it. So this was my original motivation. I started doing it in C++. I even tried using Rust. I have this honestly kind of unhinged blog post about my journey trying a bunch of different programming languages. I had this commit called Rust is too hard years before I ever wrote Zig. I felt crazy for even considering Rust on here. It's a funny blog post. But anyway, I don't mean to bash Rust. I just thought this was an amusing old blog post since I didn't know I'd be creating Zig at the time. But anyway, digital audio workstation. We have Stephen Gudekans, who works on the mock game engine and graphics toolkit. We also have the Zig game dev project by Michael Z. He's got some demos here. This is physically based rendering. He has some audio experiments. He has some physics engine. He has procedural mesh. We also have Tiger Beetle, the world's fastest financial accounting database. This is written in Zig. Congratulations to the Tiger Beetle team for recently getting independence from Coil, and they're now their own company. So they're doing great, and they're happy with Zig. And finally, we have resource-constrained environments. So for example, Jens Goldberg did this project where there was an unmanned store in Sillerud, and was considered to be a success. They ran a store for a few months where it was open at night with no employees, just running on embedded software. If you want to learn about this, you can look for this talk by Jens Goldberg. He reports that there were 0 bugs, which is a seriously impressive accomplishment. Finally, we have the Zig embedded group. This is some people who are working on trying to make embedded programming smooth and pleasant with Zig. They have a project called MicroZig, which is a unified hardware abstraction layer for several microcontrollers. We have BoxOS. Someone's working on an operating system in Zig. Looks kind of like this. Finally, we have WebAssembly 4 games. So this is a fantasy console where you can use their API to create WebAssembly games. And they recently had a game jam, and Zig was very popular in this. And there's lots of reasons why that could be, but it's a nice language for resource-constrained environments, and it goes a long way. All right, I forgot to set my timer. How much time do I have here? Ooh, I have lots of time. Okay. Gave you a break from the low-level stuff. Now we're going back into the code. So I want to give you a little taste of Zig, not to be confused with a taste of India. 5 out of 5 stars. All right, so let's get some highlights. I'm going to show you, 7 different things. So buckle in. Here we go. I want to show you array list first. This is nice and simple. This is a really good example of what I was trying to go for with the Zig language, which is that it's actually very simple, and it's just a few orthogonal concepts that work together to make it so that you can understand a lot of code. So in this example, we're implementing an array list, and the real array list has some methods in it and some dot comments and stuff. But this is really it. We just take a type and as a parameter, and we return a type as the return value, and that's really all there is to it. Though, programming languages can be pretty controversial, but most people who try Zig agree that, whether they end up wanting to use the language or not, they agree that when they use Zig, they spend most of their time, the vast majority of their time, working directly on trying to understand their application, not trying to learn esoteric language rules like in C++ or like in Rust, where you're trying to appease the borrow checker with a worthy sacrifice. You're just figuring out what your application needs, and you're solving your application's needs. Okay, so here's another example. This is inline loops. I actually hit you with this one in the very beginning, but now I'm just kind of giving it to you for real. So here's a function called dump that takes any kind of parameter. It's a generic function, and it's going to just print it, just like a debug string. And normally, if you want to write a generic printing function in your programming language, it's going to look pretty complicated. It's not going to be just 4 lines of code like this. So I'll go over this a little bit, but here's our example. So we have this struct called data, and it's got a enum, it's got an array, it's got a bool on it. Here's where we're initializing the fields, and we're calling the dump function. Inside the dump function, because our parameter could be any type, we can capture the type with type of. We just do a for loop, but it's an inline for. And we do a for loop over the fields of the struct. So this is using reflection. And because it's inline for, it's actually just secretly copying the body of the loop, 3 times. And so the field right here will be compile time known, which lets us use the field built in here, which is the same thing as just doing a.b, where b is a string. And there we go. Now we can print any arbitrary value that we pass to the dump function. So we could have created a different type here and passed it, and it would have worked. And that's that. So that's inline loops. Next, I want to show you hash maps from the standard library. We also have a regular hash map. This is auto array hash map. We also have just regular hash maps. But I want to show this one because it's got some interesting properties. So this is very similar to Python 3 dictionaries, where they're ordered, but they're also a hash map. In fact, it's implemented in a very similar way. So here we have some usage, and you can see that we're passing in integer as the key, integer as the value. And because we use auto array hash map, this function will use reflection and just that kind of thing that I already showed you in order to automatically generate a hash and equality function for you, so you don't have to. It's very convenient. And you can see that the API is pretty high level. You can just put some stuff in it. We can get some stuff out. And we're using try here because memory allocation can fail. Here's just a little example of using get or put. It's like the upsert API, where you can operate directly on the memory of the hash map. And then finally, I'm showing you here that in this data structure, the keys are all arranged sequentially in a row, and the values likewise are arranged sequentially in a row, so you can use them like arrays. Down here, I'm showing you that we're not passing a value type. We're actually passing void as the value type. And void is no bytes. And by doing this, we end up creating a set instead of a map. And it works optimally. So we're not, there's no room taken up for these keys because it truly is 0 bytes of data. And so we can do the same kind of things we can do that we did before, but now it's a set instead of a map. And finally, I want to show you that if we use the unit testing framework that we have, and we delete this cleanup, so I'm going to delete this defer here, and now we're forgetting to clean up this hash map. If I then go to run these tests, then I get a stack trace that points out, hey, memory leak detected, and it's pointing out, like, here's where you allocated memory, and it never got freed. Test failed. Next, I want to show you multi-array list. So I have another talk that this is very related to called Practical Guide to Applying Data-Oriented Design. If you haven't seen this talk that I did, I think you might like to watch it. I put a lot of work into it, and it's this talk is basically a pitch, let's be honest, right? But that talk is not an advertisement. That talk is like a lesson about data-oriented design. So I think that one's worth watching. But anyway, point is that in this talk, I talk about multi-array lists and why it's interesting. So that's on point. But here, I'll give you just like a little overview. So a multi-array list is struct of arrays. So the idea is that normally you have a struct, and if you want many of them, you say struct, 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 struct. But when you have a struct of arrays, you take each field and you put that field in an array. Then you take this second field and you put that field in an array. And you take the third field, you put that one in an array. And this can have nice properties for certain applications. So the cool thing about multi-array list is that we were able to do this in the Zig standard library. No compiler magic, no weird stuff. You can just do this with the language, with these very simple tools that we give you. So I pasted the actual real multi-array list code from the standard library onto this slide. If you take out the test, comments, and blank lines, it's 330 lines. So I just pasted on here. I'm not hiding anything from you. So here's where we see the 3 fields. If I just scroll down, I can show you, here's the set function where you can overwrite one array element with a new one. I'm not going to bore you with the details here, but you can see it basically boils down to that inline for loop that I was telling you about already. And finally, I want to show you the sort function. So I think this is one of the most beautiful places in the whole Zig standard library. If you're trying to sort a multi-array list, the idea is that you have multiple arrays in memory. So one here, one here, one here, one here. And to sort them means that you're doing the same swaps on multiple arrays. So if I'm swapping these, I need to swap it in the same corresponding place here and here, and you swap these, and so on. And so the way that the sort function works is you pass in, is anyone familiar with using the void star in C if you want a context? Can I get any head nodding or something? Yeah, okay. So here, instead of void star, you just pass in a struct that you want to be given as context. And you just pass that in as this context argument right here. So instead of void star, you just make up whatever you want, and you give it to the function, and then you're going to get it back in your comparison function. So there's no type unsafety or anything like that happening. But the cool thing is that because of methods, you can also have that context that you just invent yourself. You just put the comparison function right into there. So it serves both purposes. And it has this nice property that we can do it for, it abstracts on top of itself. So for example, this is the sort method of multi-array list, but ultimately we're just going to call the sort function in the standard library, which has the same interface. So we need to provide these swap functions. So the cool thing is we can just create our type inside this function that just embeds whatever context you gave it, and then it just perfectly encapsulates the whole thing. So we put the subcontext in there, we can reference it in our comparison function, and then, voila. I realize I didn't go into enough detail to make everyone understand it, but I hope you can see that you can represent pretty nice abstractions in a way that feels maintainable. I'm not wondering, oh, what macro or how do I know what all these lines do, right? It's just if, for, it's a struct, it's not that hard to understand. All right. So that was multi-array list. Moving on to that next bullet point. So we're moving on to C integration. I got another one of these little demos for you, and I'm going to talk over it again. So I'm going to hit play here. Okay. So in this demo, I have my side project. It's a roguelike deck builder. I've only worked on it for 4 or 5 days, so it's not very complete. But I want to show you the build.zig script here. And the point of this is that I'm going to show you C integration. So sorry, not the build script, the main function. So you can see here I'm importing c.zig, and let's go look at that really quick. So here I'm importing sdl.h, I'm importing sdlttf, I'm importing stb image for the PNG files. So I'm going to integrate with all these C libraries in order to do my little game experiment. And so how do we use this? Well, all the places where it uses the C stuff. This should look pretty familiar if you've ever used SDL. Although we do have a little advantage over SDL, or over using C, which is that we can use features like defer. So even though we're using a C API, we can still make it nicer than if we used C. Let's see, what else am I showing here? I don't know, I think I made just some silly point before I exited. Okay. So let's look at building it. Now this is going to fail because I don't have the system libraries installed. So now I'll simulate having SDL installed here, and then it will build. So I'm showing you a native build, but then we're going to look at a cross-compilation. Okay, so now we're going to build against system libraries. Everything's fine. We'll demonstrate that the project can run. So I won't go through the whole execution here. This is just like a little idea for a roguelike deck builder that I'm playing with. But anyway, you can see that it works fine. All right, Andrew, hurry up. All right. Okay, so that was a native build. Let's look at how it works to build, how to cross-compile it. So here we have the build script. And the build script it's pretty short. It's mostly just this list of C files. But there's logic here that checks, are we cross-compiling or are we doing a native build? And so the logic says if we're cross-compiling, then we have the C files in this code base, and we'll just build them from source so that we don't have to depend on the person working on the project to install a weird thing or something. We can just tell it the target that we want, and then it's going to cross-compile the build. So you can see we just list the C files we depend on here in the build script, and those are just in this project, so they're just in a subdirectory there. Now I've exited out of that shell, so you know that I don't have the dependencies to build it again, but it's not going to matter for cross-compilation because we're going to build from source. So here's the help menu for build, and we're going to just need to pass a target parameter right there. So we do zig build. Now this time I'm going to turn on optimizations, so release fast, and I'm going to pass in a target of x86 64 Windows. And the first time this is going to take a little while because it's got to build from source, it's got to build SDL, it's got to build TTF, it's got to build all the dependencies, libc, and it's doing optimizations for all of those. So it'll take a little bit of time the first time. And at least you can see it's using all the cores of the system on those little blue bars down there. Yes, compile those math functions. But now I'll show you that once we have invested in the cache, having all of these files, and there's the exe, so I could go drop that on a Windows computer, no problem, and that'll run. But I'll show you that now that the cache is populated with the dependencies, if I just go edit a file and make some change, then when we rebuild, it'll be much faster. I think maybe I had more to say than when I recorded this screen. So here I'll just make some change. I would never do this, but screen resolution of 1921. And there we go. So this time it took 2 minutes. So caching system works, cross-compilation works, C integration works. We can use all our existing code. Okay, moving on. I forgot to reset my timer. I don't know what time it is. I think I have 10 minutes. Almost done. All right, so summary. Zig Software Foundation is a nonprofit organization dedicated to improving the craft of software engineering all throughout the industry. And you can enjoy these benefits even if you never decide to use the toolchain. You can just sit back and we'll just do our best to make your life better. You can just do nothing. But if you want to, you can use the toolchain. So Zig is a C++ compiler toolchain and build system that can be used to simplify maintenance of your existing projects. And you can enjoy these benefits even if you never use the language. Just don't worry about it. Just do whatever you want. But if you decide to use the language, then Zig is a simple, powerful programming language that excels in the most demanding environments. And number of Zig users is growing rapidly. Consider becoming one of them. And consider sponsoring us if you like what we do. And that's all I got for you. So